Good day. I welcome you to the discussion on uncertainty and error analysis. Today we're going to talk about the addition of uncertainty, subtraction, multiplication, division, then we deal with square and square root of uncertainty. Let's start. Uncertainty is the magnitude of deviation from an actual value, and it is the tolerance that you have to put into consideration while taking measurements. Let's take, for instance, you want to measure the length of this book. What would you do? So, if I measure the length of this book from here to here, what reading do I have here? This should be 2 centimeters, 2.2, 2.4, 2.2, 2.3, the next one is 2.4. Between 2.2 and 2.3, I can consider the error here to be like 0.05 centimeters. Okay, so that is what brought in the concept of uncertainty. When you use any instrument to take measurement, there is some tolerance that can be given. Okay, so in this case, I can consider the length of this book to be 2.25. Okay, 2.25 plus or minus 0.05 centimeters. So someone that reads this measurement could read it as 2.2 centimeters, while someone that reads this measurement can read it as 2.3 centimeters. So there is this tolerance of plus or minus 0.05. Okay, that means the lowest value you can have will be 2.2 and the highest value you can have is 2.3. How did I get 2.2? 2.25 minus 0.05, I got 2.2. 2.25 plus 0.05, I got 2.3. So that's just the foundational concept. Now we're going to talk about percentage uncertainty, and it is the ratio of the absolute uncertainty to the actual value, okay, or actual measurement. That is percentage uncertainty. And we use the symbol, this is the symbol of percentage, this is the symbol of uncertainty. So if we take, for instance, percentage uncertainty in X, and that's how we got this, percentage uncertainty in X equal to absolute uncertainty in X divided by the actual value of X multiplied by 100%. So this is an example. Calculate the percentage uncertainty of L, given that L equals to 2.25 plus or minus 0.05. So let's assume in this case, where we measure the length of this book to be 2.25 plus or minus 0.05 centimeters. If you want to express this uncertainty as a percentage, so this is the formula we use, and we're going to do that as percentage uncertainty is in L equals to absolute uncertainty in L divided by absolute actual value of L multiplied by 100%. So percentage uncertainty in L, absolute uncertainty in L is 0.05 divided by the actual value 2.25, and then I'll multiply this by 100 and I'll express it as a percentage. So you take your calculator and then you press 0.05 divided by 2.25 multiplied by 100. If you do this, you get 2.2222 expressed in percentage. So we have to consider the number of significant values in everything we are working with. Okay, so since this is expressed to one significant value, then we can express our absolute uncertainty in the number of significant value. The percentage uncertainty rather, so percentage uncertainty in L equals to 2 point, no, I'll just write 2%. What does that tell you? That simply tells us that this value of L that is written as 2.2, this value of L that is written as 2.25 plus or minus 0.05 centimeters, it can also be written as 2.25 plus or minus 2% and everything in centimeters. So you can express the value of L as its actual value plus the absolute uncertainty. And you can choose to express it as the actual value plus or minus the percentage uncertainty. How do we convert from one to the other? You've seen how to convert from absolute uncertainty to percentage uncertainty. Once you take these steps, you get the value in percentage uncertainty. What if you want to go from percentage uncertainty back to absolute value? All you have to do, just multiply the percentage uncertainty by actual value, and then we divide the result by 100. Let's take, for instance, I want to convert 2%. I want to convert it back to its value in absolute uncertainty. What will I do? So what I will do is just to multiply the percentage uncertainty by the actual value and divide the result by 100. So this is my percentage uncertainty, which is 2%. Okay, I will multiply it by the actual value. You know, the actual value is 2.25. I multiply it by 2.25, and then I'll divide my results by 100. Okay, since I want to express it as a normal number and no longer as a percentage. So I divide my result by 100. Okay, so you know, normally if you want to cancel out these two, we cancel out. Just do 2 multiplied by 2.25, you get 4.45, divided by 100, you get 0.045. Express it to one significant figure, okay, because we've been working with one significant figure when it comes to the uncertainty. So if I express 0.045 to one significant figure, I'll get 0.05. So this is how you go from absolute uncertainty. This is how you go from absolute uncertainty to percentage uncertainty, okay? And if I have percentage uncertainty, I want to get my absolute uncertainty. This is what I will do. You get to see how we use this expression while solving other questions, okay? Yeah, but what is now the implication of this? Take note that the higher the actual measurement taken, the lower the percentage uncertainty. This you get to use this statement when performing physics practicals. You must have observed it, okay? Also, if two values are equal, if I say x equals to y, then it simply means percentage uncertainty in x must be equal to percentage uncertainty on y. Don't forget that this is the formula for percentage uncertainty, okay? If I divide the absolute uncertainty by the actual value and multiply by 100, I'll get percentage uncertainty in x, and it must be equal to percentage uncertainty in y. So if I strike off 100% from both sides, I will have this formula. And we use this formula to solve questions when talking about uncertainty. We'll get to see this along the line. What are the rules guiding uncertainty? When you are taking the sum or the difference of two quantities, you add their absolute uncertainties. What does that mean? That means if E equals to L2 minus L1, for instance, the extension of a string, then if you want to get the absolute uncertainty in E, just add the absolute uncertainty in L1 with the absolute uncertainty in L2. That's all. So now we can express E as this sum of the absolute value plus the absolute uncertainty. Let's get to see the examples where we make use of this. These are other rules. Okay, this is the rule for multiplication. When it comes to multiplication, you use the percentage uncertainty. When it comes to division, the same thing, percentage uncertainty. When you are taking the square, you deal with 2 times of percentage uncertainty. When you are dealing with square root, you do half of the percentage uncertainty. Let's solve some examples on this. I have an example here. Now, if A equals to 25 plus or minus 0.06, okay, we have 25 plus or minus 0.06, and B is equal to 20 plus or minus 0.4. Find the value of A plus B. What do? A plus B equals to, just add the two values together, 25 plus 20. You get 50, okay? Then you bring in their absolute uncertainty. Don't forget that if you are doing addition, if you are adding, then you add their absolute uncertainty. So you have plus or minus, let me bring in the absolute uncertainty. Absolute uncertainty of A is 0.6. Absolute uncertainty of B is 0.4. So by the time you bring this together, 25 plus 20, that will give us 45, plus or minus 0.6 plus 0.4, that will give us 1 centimeter. And that's how you get your answer to this. The second question that says there are 2 parts of the question. The second one says find the value of A minus B. So what will you do? A minus B equals to the value of A is 25 minus the value of B is 20. 25 minus 20, then I have plus or minus. I will now add the absolute uncertainty, which is 0.6 plus 0.4. I got 0.4 as the absolute uncertainty in B. So this is in line with the rule that says if I'm adding two numbers, I will add the absolute uncertainty. And if I'm subtracting, if I'm looking for the difference of two numbers, I will still add the absolute uncertainty. 25 minus 20, that will give me 5. Okay, then I have plus or minus 0.6 plus 0.4. I will have 1 centimeter. So this is how you deal with absolute uncertainty, okay? You just add the absolute uncertainty. What if it comes to multiplication? What will you do? If W equals to F times D, for instance, you have to calculate work done. Work is force times distance. And you are asked, find the value of the work done, given that the force is 50 plus or minus 0.8 Newton, okay? And the distance is 20 plus or minus 0.04 Newton. Which formula will you use to solve this? Then we have to talk about the multiplication. When dealing with multiplication of uncertainty, okay? Let me scroll to that formula and then we make use of it. So this is the formula we are using for multiplication. When taking the product or the ratio of two quantities, you add their percentage uncertainty. So if you have if W equals to F times D, then percentage uncertainty of W equals to percentage uncertainty of F plus percentage uncertainty in D. Don't forget that if you are dealing with addition, okay, addition of uncertainty, just add the absolute uncertainty. That is what we did here, okay? You add the absolute uncertainty. But when you are dealing with multiplication, the product of two numbers, you don't add the absolute uncertainty. You add percentage uncertainty. This symbol means percentage, okay? This is a symbol of percentage. Percentage uncertainty of F plus percentage uncertainty in D. While if you are dealing with addition or subtraction, you just do uncertainty in L1 plus uncertainty in L2. Okay, I'll come again. But if you are doing multiplication, or even if it is division, okay, if you are doing the ratio of two numbers, fine, you divide them normally, okay, but when it comes to the uncertainty in the answer, you add the percentage uncertainty in the numerator and percentage uncertainty in the denominator. And if it's multiplication, add percentage uncertainty in the first value, okay, plus percentage uncertainty in the second value. So let's take an example that involves multiplication and we solve it together. We add the percentage uncertainty. Look at this question now. Okay, this is the question we were solving. How do you get the F? Force, sorry, work equals to force multiplied by the distance. What is the force? The force is 50 plus or minus, this is the absolute uncertainty given to us. Percentage uncertainty must be expressed in percentage, okay? And if you want to get the percentage uncertainty in work, we have to add percentage uncertainty in force and add it to the percentage uncertainty in distance. How do I get percentage uncertainty in force? This is what I will do. To get percentage uncertainty in force, I will do absolute uncertainty in force divided by actual value of force times 100%. This is how I get the percentage uncertainty. Percentage uncertainty in force. I have to use this formula to get it, okay? So let me go ahead. Percentage uncertainty in force is absolute uncertainty in force, which is 0.8, divided by actual value of the force, which is 50. I will multiply this by 100 and express it in percentage. If I take my calculator and press this on my calculator, I will get 1.6%. Now let me get the percentage uncertainty in distance. Percentage uncertainty in distance is uncertainty in distance divided by actual value of the distance multiplied by 100%. What's the uncertainty in distance? absolute uncertainty in distance is 0.04. I'll divide it by the actual value of the distance, divide by 20, and then I multiply by 100%. If I use my calculator, 0.04 times 100 divided by 20, I will get 0.2%. So now I have the percentage uncertainty in force and percentage uncertainty in distance. Now what will I do? I will go ahead with my calculation. So now that simply means the percentage uncertainty in work equals to what? Percentage uncertainty in force plus percentage uncertainty in distance. What's my percentage uncertainty in the force? I got 1.6%. I will add it to percentage uncertainty in distance, which is 0.2%. 1.6 plus 0.2, I'll get 1.8%. So now I can now express the actual value as work done as what? The product of force times distance, 50 multiplied by 20, 50 multiplied by 20 plus or minus 1.8%. 50 multiplied by 20 is 1000 plus or minus 1.8% in Newton. Okay, and you may go the extra mile of expressing your answer as an absolute uncertainty. Okay, so if you want to express your answer as absolute uncertainty, what will you do? Then use that formula I gave you of how to convert from percentage uncertainty to absolute uncertainty. Multiply the percentage uncertainty by actual value, okay, and then you divide it by 100. That's how you convert from percentage uncertainty to absolute uncertainty. So I'll do that here. So the absolute uncertainty in W equals to what? Percentage uncertainty in W multiplied by absolute value of W, and I divide by 100. So percentage uncertainty in W is 1.8%, multiplied by the absolute value of W is this 1000. That is the actual value of W. And I'll divide my result by 100. Okay. So if I do all of this, I will get 18 Newton. Okay, that simply means the value of W equals to 1000 plus or minus 18 Newton. So if I want to consider the fact that I have my uncertainty here to one secant figure, I have my uncertainty in force as one secant figure, uncertainty in distance is in one secant figure, then I can express my uncertainty in W also to be in one secant figure. Okay, that simply means the value of W is now 1000 plus or minus 20 Newton. So this is how you get the value of W, okay, and stating the uncertainty in the form of an absolute uncertainty. Okay, we first got our answer in percentage uncertainty and converted to absolute uncertainty. There are other rules guiding uncertainty. We've only dealt with addition, okay, which addition and subtraction is the same thing, just add the absolute uncertainty. When it comes to multiplication and division, you add the percentage uncertainty. When you are dealing with the square of a number, okay, if A equals to B square, what will you do? As for the uncertainty here, you multiply the percentage uncertainty by 2 when you are dealing with square. And if you are dealing with square root, you divide the percentage uncertainty by 2. And don't forget that this will give you the percentage uncertainty, which you can convert to absolute uncertainty eventually. So this is an example that we are meant to solve together, okay? But because of time, I would love you to solve this example for me and then put your answer on the comment section. In the next video, I'll be solving this in detail. Stay tuned. Thank you.